Great, thanks. Thanks very much, John. Can I just get a quick confirmation that you guys actually see my presentation?
We do. Looks good.
Awesome. Yep. Excellent. Thank you. All right. Well, look, thanks for the introduction. I'm Matt Harper. I am co-founder and chief commercial officer with Invinity Energy Systems. My job at Invinity is to sell more batteries in general, and specifically to advance sort of the the market position for the batteries that Invinity builds, and ultimately that our entire industry wants to drive forward. My goal here today is good to give you a little overview of sort of how we look at the market in general, the U.S. market in particular, talk about some of the individual projects that we're currently working on in the U.S., and then talk about some of the changes in the market or the regulatory tailwinds, which we are about to be enjoying in our view. So just to start off, even though I don't need to sell to all of you, I think everyone understands the benefit of these batteries, but I thought it would be useful as a starting point just to walk you through the basic starting point for how we always talk about the need for vanadium flow batteries in the marketplace. And it comes down to this. It comes down to the fact that renewables are going to require energy storage, the fact that lithium is not going to meet all of those future needs, and the fact that we are today out there in the market proving that vanadium flow batteries are a capable and reliable source of meeting the gap between those first two statements. How we do that is, Invinity was formed in 2020 by the merger of two long-standing flow battery companies, Avalon Battery, of which I was one of the founders, and Red Tea Energy, based over in the UK. Between the two companies, we've had about 14 years of R&D investment into developing and advancing these products and technologies. Those advancements are embodied in over 73 patents that we currently have around the world. Where we are deploying those projects in general are through 50 project sites around the world. We've got over 25 megawatt hours of batteries that are either deployed today or contracted for delivery. We've got a team of, it's actually a little bit more than 110, it's about 112 or 115 now, who are responsible for executing on those deliveries. And those employees really do have a worldwide presence. The technology development and product development and some of our commercial work is primarily driven out of Vancouver, Canada, where I am today. Some of our, especially our solutions development and sales and commercial activities are based out of the UK. We've got a sales and executive office down in the Bay Area in the US, and then a lot of our manufacturing happens at a facility that we operate in Suzhou, just outside of Shanghai. This gives you a little bit more of a detailed view into exactly what that operational footprint looks like. As I said, Vancouver is where the design and manufacturing takes place. Because we are a London listed company, a lot of our sales and our investor relations happen based out of London, and our sort of capital raising and whatnot. The UK and Vancouver respectively are the two centers of where we do what we refer to as solutions engineering. So taking the basic battery itself and turning it into something that is actually sort of beneficial and useful for our customers. All of that, that solutions engineering requires as an input the core technology, and it's embodied in our cell stacks, which we manufacture primarily in Vancouver, but also in Bathgate, and our balance of system, which comes out of China. So, the flow is balance of systems components and cell stacks come together in Bathgate and in Vancouver, and then those get distributed to either the US out of Vancouver or to the UK and Europe out of Bathgate. So from that global operating base, where are we deploying some of these projects? And this is sort of a subset showing some of the main projects that we're currently working on. To start from east to west, one of the biggest projects that we did as Avalon a couple of years ago was a 2 megawatt hour project in China with a company called Huanghua Hydro. More recently, we have announced and are currently building a project in Yadlamalka, which is in southern Australia. We refer to this as the world's largest solar powered VFB. It's 6 megawatts of solar DC coupled directly into 8 megawatt hours of batteries. And the purpose of that project is to allow solar to serve what is fundamentally a very, very highly constrained electric grid. Over in the UK, we're working on projects not only related to renewables integration, but overall sort of grid services and grid balancing. We are midway through the construction process on our Energy Superhub Oxford project. This is a 2 megawatt, 5 megawatt hour battery that is going to be a hybrid battery with a lithium ion array that together will be serving the electric grid in Oxford, helping to alleviate not only the problems of renewables integration, but also things like electric vehicle charging and other congestion on specifically the UK transmission grid. This is a directly transmission connected project. Finally, as we get sort of furthest towards the west here, and into the topic of today's primary discussion, our projects in the U.S. The one that you see in Iowa here is what was at the time our largest behind the meter solar plus storage project. This is a 1 megawatt hour battery connected with about 1.2 megawatts worth of PV generation at a university. This university wanted to install solar, but didn't have a sufficiently flat load profile to make use of that energy all the time. They weren't in a jurisdiction where they could get a lot of money out of net energy metering arrangements. And so because of that, it made a lot of sense for them to install that battery, absorb the excess energy produced off the solar panel when their university doesn't need it, and then use those batteries to mitigate peak demand at other times during their day-to-day operations. Finally, probably the most interesting project in California we're building right now is a 0.5 megawatt hour system in Saboba, which is powering critical infrastructure. Certainly, one of the things that is most exciting about the U.S. market right now is some of the critical infrastructure resilience. Especially because of some of the wildfires that are happening, and that we see as a driver, not just for this project, which I'll talk about in a little bit more detail in a minute, but also for a lot of our similar and larger projects that are going to be coming along in we believe in the next months and years. Just to give you a bit of a deeper dive into some of those U.S.-based projects. So we talked about I talked about the Maharishi University project. Again, this was really designed to deliver greater use of self-generated renewable power. This is a small university campus that does not have huge electrical loads, and so the 1 mega or 1.2 megawatts of solar that they had installed was being underutilized, or was going to be underutilized. Based on their economic projections. It turns out in the last year, it has been significantly underutilized, as you can imagine. So the batteries have been doing, dual service, really providing a big part of their overall load because the university has been essentially shuttered through the pandemic. But this project is a project we deployed a little over 2 years ago. It's doing peak shaving, and because there's no net energy metering in this region, really, any solar that's not absorbed, that's not used, the instant it's absorbed is wasted. So, the real fundamental goal here was to take that, essentially zero value excess energy and turn it into power that could be used as needed. If we look from those previously deployed project, which is among a fleet of about a dozen sites that we've got currently up and running in the U.S., I thought I'd give you a look into two of the projects that we are currently contracted for and in the middle of building. The first one is the Saboba Fire Station that I touched on briefly on the previous slide, but wanted to sort of give some more detail here. About a year and a half ago, the California Energy Commission came forward with a request for proposals for the combination of renewables and long duration storage systems that could help alleviate challenges around critical infrastructure resilience and around underserved communities. This is obviously the former of those two. Essentially, the challenge that the Saboba band of Luiseño Indians were facing, and that this project is intended to solve, is that their whole community is fairly remote, and in the event of a wildfire, they rely very much on this fire station for not just response to the fire itself, but as a rallying point for the community to provide emergency services and emergency activities coordination. What that means is that they need to be able to take this site offline, off the grid, for comparatively long periods of time. And so what we were able to do at this project is install not only our batteries alongside solar for kind of managing the providing power on a day-to-day basis, but also to use that battery and solar combined with some building level controls to get to the point where in the event of a power outage, this facility can be totally self-sustaining for not just a few hours, but days to weeks on end. The fundamental operating mode here is that the solar panels recharge the batteries allow the facility to operate 24/7, and together those things mean that this facility can stay up and running. What's been interesting about this project as we've gotten into it is there are a lot of people who thought that this would not work. There's a real misconception in industry about vanadium flow batteries not being able to serve, resilience. Oh, well, don't you have to turn the pumps on? Doesn't that take a while? How does this work? Can you do black start? All these kinds of things. Those are definitely technical challenges, but they're technical challenges that are surmountable. And one of the things that we're really doing is trying to alleviate some of those misunderstandings, or correct some of those misunderstandings in the market, by providing this sort of critical infrastructure resilience at this and similar projects. Similarly, within that same CEC program, we are developing a project that is going in at the Air Station Miramar. This is I'm excited because I'm a nerdy kid who grew up in the '80s, and this is the site. This is where Top Gun was filmed, which we're all really excited about. Very similar situation here. They've taken a slightly different approach. I mean, obviously, the critical infrastructure resilience for a naval air station like that, Marine Corps air station like this, is front and center in terms of what they try to achieve. They need to make sure that when the grid goes out, they've still got power. This is an interesting case because we are up against and hybridized with a couple of other technologies. There are also flywheels on this site. There are also non-vanadium flow batteries at this site. And so, this is a bit of a head-to-head battle to see, who can do what. I talked a bit, in the context of our Saboba project about that resiliency. Can a vanadium flow battery provide that black start capabilities? And Webcor, our partner in this project, was of the opinion that doing that would be challenging, and they needed to have different technologies, standing side by side us in a hybrid configuration in order to make that happen. Our view is that that's not necessary, and this is going to give us a chance to, in a side-by-side basis, prove that we can be a suitable fit for those resiliency projects. So, with all that said, that's sort of what we're currently working on. The sort of macro level outlook is extremely positive. Gavin Newsom, the California governor, has said that he's going to put $350 million towards pre-commercial long duration storage projects. That's code for everything other than lithium. We've been talking pretty actively with some of the players in the regulatory side in California and elsewhere, and trying to drive forward our agenda, which is that in terms of those non-lithium alternatives, vanadium is definitely the most mature, the most advanced, and the most fit for purpose for what they intend to achieve. There's even sort of at a national level, there's a lot of money being pushed in this direction of alternative long duration storage means. There is, the Department of Energy's Advanced Manufacturing Office announced about 6 months ago a $20 million grant for advancing the flow battery supply chain in the U.S. Those applications are ongoing, but we expect that whether those funds flow to us or to others, it's really going to advance the state of capability for the manufacturing and supply of these products domestically. With that, that's our view. I'll pass it back to you, John, and look forward to some great questions later on this hour.
Yeah. If anyone has a specific question for Matt, you can ask it now. Otherwise, we'll switch on to the other panelists and then open it up for general questions of our panelists.